Okay, so as I said, I was going to talk to you guys today in the screencast about how to balance chemical equations. And I had you take this screenshot, or I had you take a picture actually, of this sort of how-to steps. And we're going to go through this process. So it's worth it if you haven't done so already. Make sure that you import the photo that you had into a Notability document so you can have these 5 steps. And we'll go with it. All right, so let's take a look at some examples of what to do. Now, actually, I think I'm just going to move to a new page. Let's imagine that I have a statement, a chemical statement, that it's not balanced yet. I'm going to start off easy, and we're going to move to more difficult ones. So we're going to go with, whoops, there we go. Okay, we're going to go with solid magnesium is combined with titanium tetrachloride and wonder what that is in terms of the state of matter. Let's just say it's also solid, and the products that form as a result of the combination of that chemical reaction are magnesium chloride plus elemental titanium. So we'll just say these are all solids, just to keep things simple here. And the first thing you should notice, obviously, when you do this, or the first step you should take, I should say, is this whole concept of writing the chemical formulas and then locking in the subscripts. So let's take a look at this again. With titanium, okay, titanium has a common ion charge of +4, which is why you need to make sure that you have the chloride ions, which are each -1, that you have 4 of those to balance out and make it have a neutral entire compound that we've got here. No charge on elemental magnesium. And then when we take a look at magnesium down in this situation, we know that magnesium itself, because it's an alkaline earth metal, is going to have a charge of +2. And just like we said moments ago, the chloride ion is -1, so to balance that out, you need to have 2 chloride ions for every 1 magnesium cation. And then we look at titanium, and it will not have a charge because it's in its elemental form. So we have to lock in on these subscripts that we have associated with the chlorines. All right? And in fact, you should understand that there's no subscript written between the titanium and the chlorine and the magnesium and the chlorine here. But you can assume that if nothing's there, then it is a coefficient of 1. Okay, so that took care of that step number 1, locking in on the subscripts. Then we're going to do this number 2 thing here. We're going to create our tally chart and then count up the atoms before we do anything else. So let me, let's see, I made this kind of too big. Maybe I can move this into here. Well, that's not ideal, so I'll have to move things around a little bit. I wish there's no way of shrinking it, huh? Oh well, sucks for me. I'm going to have to deal with this, move things around. So we take magnesium, titanium, and our chlorine, and then we can go ahead and take that. Oh, whoops, did not mean that. Okay, I'm going to select up this group and paste it right here. Okay, and put little colons here because this is where our numbers are going to be. This is a very important thing to do because if you skip this step, at least initially when you skip this step, then you start losing track of things very quickly and it gets bad for you. So magnesium, you can see here that we only have 1 magnesium on this side, so I go ahead and put in my 1 here. Titanium, we only have 1 of those. And then my chloride ions, or chlorines, got 4 of those dudes. Okay, and then we shift our attention over to here. We have magnesium, just 1 of those. We have our titanium, just 1 of those. And then we have our chlorines, and we have 2 of those chlorines. So right off the bat we can see here that we have too many chlorines on my reactant side, or not enough chlorines on my product side. So in fact, the next step we want to do is you start with the singles if possible. Now, what I mean by that is if you take a look here, chlorine is, well, all these are going to be actually okay to start with, but chlorine is not found in two things on one side of the equation. So for example, there are going to be some reactions where you could imagine that chlorine would be associated with this fellow over here and this fellow over here. And then that would not be the one you want to select. Okay? You want to go for one that's only found in one thing on one side of the equation. But in this case, you can see that that's the case for all three of the atoms or elements that we're working with. The magnesium is by itself over here, and then it's only found in one of the two things on this side. Titanium is found in one of the two things on this side and by itself over here. And then you can see that the chlorine, it is found only in this one, it's not found over here. And it's only found in this compound, it's not found associated with the titanium. So you could start with any of them, but clearly it makes a lot of sense to start with the thing that's out of balance. You know, obviously, to increase the number of titaniums or magnesium wouldn't make any sense because they are in balance right now. So you really want to go for this. You want to go for the chlorine. And since we have too few chlorines on this side, you've got to increase the number of chlorines on the product side. So to do that, obviously, I think you can see I need 4 of them. So that means I'm going to multiply the chlorines times 2. But if I do that, I have to multiply the entire compound in which the chlorine is found times 2. Because remember, we're talking about coefficients, and these coefficients distribute themselves throughout the entire compound. So I'm going to use green, and I'm going to start off with a 2. I'm going to start off with a 2 because this 2 that we have right here times the 2 that we have as a subscript is now going to allow me to change my number here. Instead of having a 2, and I'm just going to cross it out, I'm now going to have 4. Now, once you do that, once you make any change, now you have to go through and make changes to everything in your tally sheet. Now, I haven't changed anything on my reactant side, so I don't have to worry about that. On my product side, I do have to worry about things, though. So magnesium now has just changed because I have the 2 for my coefficient times the 1 that doesn't exist here, but we can assume exists here. So that means I now have 2 magnesiums. My titaniums haven't changed at all. So in a sense, we can say we are set with this and we are set with this because they're the same number on both sides of the equation. But clearly, we're not completely done because now we have a situation where magnesium, we have 2 of them on this side, and over here, I only have 1 magnesium. Now, I think all of you probably know that all you need to do now is put a 2 in front of this magnesium because it doesn't affect anything else to do that. And when I do that, now I can go through and I can cross out the 1 that we had associated with magnesium initially on the reactant side. I can change that to 2. And you can see it doesn't change anything with our titanium or our chlorine. Right? And now we can see that we have the same number of magnesiums both on the reactant side and the product side. So all we needed to do to balance this equation was put a coefficient of 2 in front of magnesium, coefficient of 2 in front of magnesium chloride, and we have a balanced equation. All right, so that's an easy one, and I took us through that impossibly slowly and probably bored you to tears, but I need to make sure that you understand how to do that process. Oh, I guess I sort of bailed out on this. So, as I said, you're going to start with the singles. There wasn't really any reason to start. All of them were singles. And then in the next step, tally your atoms again. Remember, I did that each time, making sure that every time I change something, I change the tally of my atoms. And then, obviously, in the very end, we adjusted coefficients and kept on tallying until things balanced out for us. A lot of it is trial and error. Simply all there is to it. Trial and error. All right. So let's take a look at a different chemical reaction here. And this time I'm going to play it smart. I'm going to write it small so that I can fit it in here. We're going to go with calcium hydride, which is a solid. You know, I'm going to leave out the solid liquid. No, I guess I should put it in. Otherwise, you guys are going to get lazy and leave them out too. So, solid calcium hydride plus water, and that will be in liquid form, leads to calcium hydroxide, and that's actually going to go into solution. So I have AQ there. That's a Q. Let me try that again. That's better. And hydrogen gas, and this will be a G. Okay, so there's my chemical statement. It's not yet an equation. First, let's go through and do the same thing we've done, though, in the past. I just showed you moments ago. So check and make sure that your the compounds are all correctly balanced. If we take a look at the calcium, calcium is going to be a 2+ ion, and that means, and each hydrogen is -1, so you need to have 2 hydrogens to balance out the +2 charge on the calcium. So that is set. Water is a molecule, so we know it's H2O. If you wanted to, I suppose you could prove to yourself that it works. If you do a Lewis dot structure, you satisfy the octet rule, so all is well for that molecule. All right, I'm just going to go ahead and erase this because we don't really need to have it in there. And we move to the calcium hydroxide. Hydroxide is a polyatomic ion with a charge of 1. Calcium still remains at a +2, so that means you're going to need 2 calcium hydroxides for every 1 calcium. Or, I'm sorry, you're going to need 2 hydroxides for every 1 calcium to balance that out. Again, I'm going to erase this because we don't need to keep it there. And then lastly, we have diatomic hydrogen. And again, if you want to satisfy the octet rule, you'd be able to show it like this. And of course, hydrogen is an exception to the octet rule. It's totally comfortable having only 2 electrons as a valence electron. All right, so we know we're set with the way that we've set up the chemicals properly, the chemical formulas for each one of these properly. So then we do the next thing. Now, what I'd like for you to do is I'd like for you to pause the screencast right now, and I am going to have you try to balance this equation following the scheme that I've showed you how to do, and then come back and see if you got it right. Okay, so take a moment to pause, and then I'm just going to pause myself for a moment so it gives you a chance. Okay, you know that you got it right if you have no coefficient in front of the calcium hydride, but you have a 2 in front of the water molecule, no coefficient in front of the calcium hydroxide, and a 2 in front of the hydrogen gas. All right. Now, if you didn't get that right, it's worth it for probably to have you follow through with what I'm showing you here. If you got it right, you can probably skip to the next one. But let me go ahead and show folks who didn't get it how to go about doing this. Okay, so first thing you need to do is set up the tally, like I've said. We only have 1 calcium on this side. We have 2 hydrogens here and 2 hydrogens here, so a total of 4. And then we have the 1 oxygen that exists here. Over on the product side, we still have our single calcium right here. There's no coefficient here. Yes, there's a coefficient here, but it has to do with the polyatomic ion hydroxide. So ignore it when it comes to the calcium. So calcium has, you could imagine, a subscript of 1 here, which means we only have 1 calcium on this side. With the hydrogens, this is where it gets just a wee bit tricky. We have the 2 hydrogen ions over here, or I'm sorry, 2 hydrogen atoms over here. And then we also have 1 hydrogen atom in here, but there's a subscript outside of the parentheses indicating that you actually need to distribute this 2 to each piece that's inside the parentheses. In that case, we're going to have not only the 2 hydrogens, but 2 oxygens associated with this as well. So if it's 2 hydrogens here, and then you have 2 of them here, altogether you get 4. And then obviously you take that 2, multiply it by the assumed 1 that you would have as a subscript here with the oxygen, and that's going to give you a total of 2 oxygens. All right, so it looks like the calcium is okay on both sides, the hydrogen's okay on both sides, but clearly we don't have the right number of oxygens on our left side or our reactant side of this reaction. So what do we need to do? We need to go ahead, oops, I just erased that thing, sorry. We need to go ahead and put on a coefficient that will allow us to balance out the oxygens. Okay? So I'm going to use That's red. We'll go with red here. Since I don't have enough oxygens on my reactant side, I want to make sure I increase that. So I'm going to go ahead and try to put a 2 here as a coefficient. Notice you can never add subscripts. You might be tempted to want to put a 2 here. You can't do that. That's an illegal thing to do. You can only use coefficients in the front of an entire compound. All right. So once you set up your chemical reactions in your statement, you've already made your subscripts. Lock them in. They cannot change. All right. So now we have, instead of having just one oxygen over here, I have 2 oxygens. And now that looks good, right? So now you have, boom, that works and that works. But of course, by putting in 2 oxygens, 2 in front of the water, now I've just thrown my hydrogens out of balance. So in fact, I can no longer have a cute little check mark here, and I have to cross out the 4, because now I have the 2 times the 2, which is 4, plus I have another 2 over here, right? So I have 6 hydrogens all together. Shoot, that really messed things up, didn't it? Because now I have to go over to my product side and figure out how to change that. Now, it would make some sense, right? Oh, I have too few than I should, so why not just put a 2 in front of here to satisfy it? Because that's going to give us, right, the right number. We're going to have 4 hydrogens plus a 2 here. That'll give us 6. Well, there's no doubt that's a step that you could take. However, this is where it's kind of tricky. It's always better to mess around with a 1 that's all by itself. All right, it's just going to simplify things greatly to do that. So in fact, instead of going for changing the number of hydrogens in the compound calcium hydroxide, I'm simply going to change the number of hydrogens associated with hydrogen gas. So if I decide then to put a 2 here instead, I'm still going to have 6 hydrogens altogether, right? You're going to see I have this hydrogen times 2, which is 2, plus the 4, 2 times 2 here, that I get here. So this gives me then a total of 6 hydrogens. Now, lo and behold, those 2 work out. And since I didn't mess with anything regarding the calciums, right, I avoided messing with the calciums, then I know my calciums are still intact in terms of the law of conservation of matter. So there you have it. You have the 2 in front of the water, 2 in front of the hydrogen, and that balances your equation. All right, I'm almost done. I just want to write down one problem for you and have you guys do this one, and then I'm going to give you the answer. I shouldn't have done that. Whoops. I'm going to give you the answer, and I'm going to see if you can come back and figure out how one arrived at that answer. So there's my reactants. Here are my 2 products. Oops. I have no idea what that is. I know this is gas. Let's just pretend this is solid as well. Alright, so I want you to pause it, try to sort this out, and figure out what it is that you need to put in for coefficients. Again, I'm going to count 10 seconds, and I'm going to pause, so make sure you pause too, so that you don't see the answer before you need to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, pausing. Okay, and you can see here that the answer would be to put a 3 in front of here and a 2 in front of here. Hope you got that one. If not, try to work it out, and if you still can't figure it out, make sure you talk to me in class the next time we meet. Okay, see you folks.